So what's a partial fraction decomposition? You take one fraction and you break it up into two or more fractions. Well, how can we do this? So let's say we have some fraction, 1 over x plus 2, and we're trying to add it to some other fraction, 3 over x minus 4. Well, we know that when we multiply any term by 1, we get the same term back. So this is the same exact thing as that. Okay, so we also know that x minus 4 over x minus 4 is equal to 1, and that x plus 2 over x plus 2 is equal to 1, because they're the same term, right? So now what we can do is we can multiply by 1, basically, without changing the actual expression. So we'll do that here. And what we're trying to do here is we're trying to make a common denominator so we can add up our terms. So here, what we'll end up with is x minus 4 over x minus 4, x plus 2, and we're going to add that to 3x plus 6 over x minus 4, x plus 2. And we know that we can add these terms together because they have the same common denominator. So what we end up with is 4x plus 2 over x minus 4, x plus 2. What we see is that we combined these two fractions, and this is the same term. Well, partial fraction decomposition is the same thing, but in reverse. We're going the other way. So how can we do this? So let's say we start with 4x plus 2 over x plus 2 times x minus 4. We know that this is equal to some two fractions, right? A over x plus 2 and b over x minus 4. Well, we can multiply these terms by 1 as we did previously, right? So what we can do is x minus 4 over x minus 4 here, and we can do x plus 2 over x plus 2. What we end up with is an equation like 4x plus 2 over x plus 2, x minus 4, which is equal to a over this term, because we just made a common denominator, and we have that same denominator over here, right? And we have b, and we're adding this together. So, and we also can't forget this. So, what we can do is we can get rid of the denominator since it's the same on both sides, right? And you can say 4x plus 2 is equal to a times x minus 4 plus b times x plus 2. So now, what we want to do is we want to choose a value for x so that either this is 0 or this is 0. So let's say we want x equal to 4 or x equal to negative 2. So let's say it's equal to 4. So we get 4 times 4 plus 2 equals a times 0, which is just 0, plus b times 4 plus 2, which is 6b. So we get 18 equals 6b, and we're left with b equals 3. Okay, so now let's do the same thing, but for a, for the other term. Right, so let's plug in negative 2. 4 times negative 2 plus 2 is equal to a times negative 2 minus 4 plus b times negative 2 plus 2, which we know is 0, right? So what we get is we get negative 6 is equal to a times negative 6, and we get that a is equal to 1. So if we go back here to this equation right here, let's plug that in and see what we get. So it's the exact same equation, right? So we get that 4x plus 2 is equal to x plus 2 times x minus 4 is equal to 1 over x plus 2 plus 3 over x minus 4. And what's crazy is that that's the same thing that we started with all the way back here. So that's how partial fraction decomposition works. So basically, you take the term here, and you take the term here, and you split the factors up into these two fractions, and you say, what's going to be on top? There are a few more things we need to know. Let's say we have repeated factors in the fraction. Then we're going to do our partial fraction decomposition like normal, except we're going to have a bit of a special term. So here we have a over x minus 2 as we expect, plus b over, here's the special term, x minus 2 squared. instead of x minus 2. And finally, we have c over x minus 1 as we can expect. So for every single repeated term here on the left, we're going to add an extra term to the right. So if this was cubed, we would have to add a fourth term in this case. We would have x minus 2 cubed here. And if it was fourth, we would have a fifth term, and this would be to the fourth power. And we can continue that forever and ever, but we're not doing that today. So we're just going to continue with this. So in this case, we know that a times x minus 2 times x minus 1 plus b times x minus 1 plus c times x minus 2 squared is equal to 1. And now we're going to solve that. We're going to pick values for x such that some of these terms cancel out. So we know that we have to have x equal to 2 or x equal to 1. So let's say we choose x is equal to 2. Then we're going to have all the terms cancel out except for b times 2 minus 1 is equal to 1. And so we see b is equal to 1. Now let's say x is equal to 1. The only term that doesn't cancel out is the c term. So we have c, 1 minus 2 squared equals 1. And what we end up with is c equals 1. So how do we solve for a? So for a, what we're going to have to do is we're going to have to pick a random value for x, and we're going to use the values of b and c that we know in order to solve for a. So I decided that I want x equal to be 3 in this case. So we're going to plug in 3. So a times 3 minus 2 times 3 minus 1. And we know what b and c are, so we can just plug those values in. We're going to get this equation. So here we see 2a plus 2 plus 1 is equal to 1, right? We're going to get 2a equals negative 2. And now we know that a is equal to negative 1, and we are done with our partial fractions decomposition. Let's talk about when we might want to use partial fractions and when we might not. So in some cases, we just can't break down the terms any further, and so we shouldn't use partial fractions because there's nothing to do with partial fractions. And in some cases, we should just use algebra in order to solve the equation. And in other cases, we have partial fractions with division, and we're going to go into an example problem. How do we know when to do division? The maximum degree of all the terms in the top will be greater than the maximum degree of all the terms in the bottom. So here we see 3 is greater than 2, and we know that this number is the degree. I'm going to run through this division real quick, just so you kind of remember how polynomial division works. And here we get 4x squared minus x. We bring down the 1, do the same thing that we just did, x, and then minus 8, and we're left with 11x minus 7 as the remainder. And up here, we're left with x plus 4. And so we're going to bring these terms down here. So here we have x plus 4 because we performed the division. And since 11x minus 7 is the remainder, we're going to leave it divided by x squared minus 3x plus 2. And from there, we can do partial fractions decomposition on the rest, and you should know how to do that for this term. And don't forget, math is for everyone.